Okay, today's lesson is going to be on one variable inequality word problems. So it's going to be very similar to what we've been doing before. The only difference is now we're going to be having word problems on this. And I don't know why, but there you go. It was part of it wasn't showing up, so sorry about that. So it's a lot of problems and it's going to take a while, but we're going to try to run through this as fast as possible. It's stuff that you already know how to do. However, the hard part is going to be setting up the situation. So on certain problems, I maybe not won't solve the entire thing, but we'll just see as we go along. So it says Elisa won 40 lollipops playing basketball at the school fair. She gave two to every student in her math class. She has at least seven lollipops left. Write an inequality to represent the situation. Be sure to define your variable. Now, when they say define our variable, we're going to try to define what our x represents. So let me go ahead and start with maybe like a statement on the side. On the side, let me just go ahead and go over a couple of things. If they say something like at least, then they're saying like, they need to have at least 10. Well, that means 10 or more, right? So that means your number needs to be greater than or equal to whatever number that they're talking about. The opposite of at least would be at most. At most means there's like a limit as to how high your number can be. And if there's a limit as to how high, then that means they want the number to be less than or equal to. If they say something like, I need something to be more than, then that means they want their number to be greater than. And the opposite direction would be if they say they want something that's less than, then it would be like this. There is a word or a couple of words that they can sneak in the front and it completely changes the meaning. And we'll talk about those numbers once we get there. Okay. But for right now, this is kind of like our little code to let us know when I should be using what. So Elisa won 40 lollipops playing basketball. She gave to each student. She wants to have at least seven lollipops left. So that at least seven is telling me that they want my x or my number to be less than 7 or less than or equal to 7. Sorry, I got that completely backwards. I kept looking at it like, what the heck am I talking about? We just said that the word at least means greater than or equal to. Sorry, guys, it's been a long day. Greater than or equal to 7. Sorry. All right, now here's where it gets a little bit weird. It says Elisa won 40 lollipops. So I know she's starting off with 40, but every single time she sees a student, she's going to give two away. So if she sees one student, she's going to give two away. If she sees two students, she's going to give four away. If she sees three students, she's going to give six away. She's counting by twos in this instance. And every single time she sees a student, the number of lollipops goes down by two. Now, I don't know how many students there are. So I'm going to use my variable x, which leads me going back to this part where it says, be sure to define your variable. Our x is usually going to be, not always, but it's usually going to be the thing that we're looking for. So it says, find the maximum number of students in her class. Sorry, I'm trying to highlight that. I told you today was a long day. The number of students in her class, so we're going to say let x represent the number of students in her class. Now that we have this, and I really should have highlighted this last piece. Now that we have this set up, we're just going to go ahead and solve this. Now, I know that first of all, this problem is really difficult just to set up. But the more you're going to see this, the easier this is going to become. So let's pretend that there was only three students. Then the way that this would work is she started off with 40 lollipops because she saw three students. Then she's going to take away six lollipops. 40 take away six would be 36 lollipops left over, which is definitely greater than or equal to the 7 that we want. So this is working. That was my little check on the side. Let's go ahead and solve for it, though. Let's see what we would get. I'm going to have 40 minus 2x. It's greater than or equal to 7. I'm going to solve for that x. That means I'm going to subtract 40 on each side. This is negative 2x is greater than or equal to negative 33. Now, I did this in class the wrong way on purpose. I'll do it here as well. I'm going to do this wrong. So I'm going to divide both sides by negative 2. And x is greater than or equal to, what is that? 33 divided by 2 is 16.5. Now, hopefully you spot where the mistake is at here. Because when we divide by a negative, remember, we need to change the direction of that symbol. So it's technically not a greater than or equal to anymore. Now it's a less than or equal to. Okay, so let's just remember what it is we just found out. X represents the number of students that will allow her to have more than 7 of these lollipops. But you can't have 16.5 students, right? So if you want to have less than that, then that's saying that the max number of students in the class is 16. Because again, your number needs to be less than 16.5. Obviously, you can't have 0.5 students, so that doesn't make sense. So we're going to go with the number 16. Sometimes you're going to change that number to a whole number. Sometimes you're going to leave it as a decimal, depending on the situation. All right. Again, the first one's the toughest one. Hopefully, the next few will start making be a little bit faster and make it a little bit more clear. It says more than 450 students went on a field trip, 10 buses were filled, and 5 more students traveled in a car. I'm going to write the inequality to represent the situation. Be sure to define my variable. Again, your variable is going to be most of the time the item that you're trying to find. And in this case, I'm trying to solve the minimum number of people on each bus. So I'm going to say let x represent the minimum number of people in each bus. Again, usually it's going to be exactly what the question is asking you for. Okay, well, let's see. Is there any words that they said? Well, they said that I want more than 450 students. We go back to our notes. More than means they want it to be greater than 450. So I know how my inequality is going to end. Now it's just how am I going to fill up the next stuff? Well, the first thing that we want to kind of figure out is there anything that you know for sure? Like for sure, I have. Well, there's 10 buses, but I don't know how many people are in each bus. So the 10 buses I'm not really going to work with yet. I do know that there were 5 more students that traveled in a car. So that means exactly 5 extra students traveled in a car. So that's not saying that I'm counting by fives. That means I'm going to add 5 extra students at the very end. So if 10 buses were filled, what that's saying is like if I put 2 students in the 10 buses, it would be 2 times 10, which is 20. If I put 3 students in the 10 buses, that'd be 3 times 10 is 30. So it looks like I'm counting by tens, right? Depending on how many people I'm going to put in each bus. If it's just 1, it's 10. If it's 2, it's 20. If it's 3, it's 30. If it's 4, it's 40. I don't know how many students I'm going to put in each bus, but I know I'm counting by tens because there's 10 buses. So we're going to say that there are 10x students riding on the buses. So if I put 9 people on each bus and there's 10 buses, that's going to be 10 times 9, which is 90. I'm counting by tens in this case. Now that should take care of all the students. Let's go ahead and solve this. I have 10x plus 5 is greater than 450. We're going to subtract 5 from each side. I got 10x is greater than 445. I'm going to divide each side by 10. X is greater than, now remember our trick here, when you're multiplying by 10, you move the decimal 1 time to the right. That means if we're going to divide by 10, we're going to move the decimal 1 time to the left, which means that decimal is going to go here and it's going to become 44.5. And I just realized I put the equal sign. I should not be using the equal sign. I should be keeping the same inequality. And let's just realize now that I have it, I know that x needs to be greater than 44.5. What did x represent? X represented the minimum number of people on each bus. And that's saying I need to have at least 44.5 people. Well, you can't have 44.5 people, so the least number of people on each bus needs to be 45 if we want to spread them out evenly. So the least number of people on each bus is 45. All right, let's try the next one. It says Bill spent $26 on a magazine and 5 composition books. The magazine costs $4. Write an inequality and then define our variable. Let's go ahead and define the variable first. Let X represent. What is it that I'm trying to find? I'm trying to find the maximum cost of each composition book. So let X represent the maximum cost of each comp book. That statement I got from that yellow highlighted portion. So I defined my variable. How is my inequality going to end? Well, it says that Bill spent less than $26. So I want to have less than $26 over here. Is there anything I know that got charged like do I know anything like it's a fixed number? I sure do. It says I bought a magazine and 5 composition books and they told me that the magazine cost $4. So I know for sure I have an extra $4 charge here because of that one magazine. What I don't know is how much it cost me for the 5 composition books. If each composition book costs $1, then it'd be 5 times 1. If each composition book costs $2, then it'd be 5 times 2. If it's $3, then it's 5 times 3. It's going to be X dollars because I don't know the cost. So I'm going to write 5 times X. 5X plus 4. We're going to go ahead and now that we have that solved, sorry, I just realized I forgot to highlight this part. Now that I have that set up, let's go ahead and solve it. I got 5x plus 4 is less than 26. I'm going to subtract 4 from each side. I get 5x is less than 22. Divide both sides by 5. Now you can do long division on that. I'm not going to. I'm just going to, I've done this problem a few times today. So it's going to be x is less than 4.4. Now when we say 4.4, we have to be careful, because you're not going to go to the store and get charged $4.4. Remember, X represents the maximum cost of each composition book. It doesn't make sense for it to cost $4.4. So we're going to add an extra zero at the end, and now this becomes $4.40. That is to say, the max price, the price of the book, of each book, needs to be less than $4.40. All right, so we've done a couple of these problems. Hopefully it's going a little bit smoother for you now. We're going to jam through the rest of these. It says Amanda rented a bike from Shauna's Bikes. They charged $2 per hour plus a $10 fee. Amanda paid less than $27. So I see that we're spending less than $27. That gives me a clue that this is going to look like this. And what else? I need to write my variables. So I'm going to say let X represent. What am I trying to find? I'm trying to find the max number of hours Amanda rented the bike, the max number of hours she rented the bike. What are they going to charge her? Well, they're going to charge her $2 per hour. When they say per hour and I have X hours, that sounds like a 2X to me, plus a one-time $10 fee. So right away, they're going to just charge you the $10. So that means I should be writing 2X plus 10. Now that I have it set up, let's go ahead and solve this. I forgot to highlight this in yellow. Let's go ahead and solve this. It's going to be 2x plus 10 is less than 27. We're going to subtract 10 from each side. Again, this part I'm going a little bit quicker on because you should be comfortable solving for these inequalities. We've done enough of this where you should be good with this. And 17 divided by 2 is going to give me that 8.5. This is where it gets a little tricky. Um, what does X represent? X represents the number of hours that she can ride this bike for. Can she ride this bike or rent this bike out for 8.5 hours? Honestly, it kind of depends on the company. Some companies, when you rent it for like 8.5 means 8.5 hours, they'll charge you for the extra half hour, right? Some companies, if you ride it for 8 hours, they'll charge you for 8 hours. If you ride it for 8 hours and 1 minute, they'll charge you for 9 hours. And since this one didn't really say like which one's which, I'm just gonna say, you know what, they're gonna charge me for the 8.5 hours. I'm gonna leave it as 8.5. So the max number of hours, the max Amanda can rent the bike for, I said can rent the bike is 8.5 hours, less than 8.5 hours. Any number less than 8.5 hours, she's going to be able to spend less than $27. All right, you need to buy some pencils and an eraser. You can spend no more than $5. The eraser costs $1 and the pencils cost 25 cents. Hey, be careful on this one because I see this. It says more than $5. When I see more than $5, it sounds like this. More than $5. However, we have to be careful with that question because it says you can spend no more than $5. Like if you spend $6, it's too much. If you spend $7, it's definitely too much. If you spend $4, that's fine because it's no more than $5. Hey, remember when I was talking about earlier, like we have to be careful with these statements because there's this word that you can stick in the front and kind of changes everything. That's the word. If you have something that kind of negates it, that totally changes your inequality. So if I say no more than five, then five is your limit. Is it okay to spend exactly five? Yeah, if you spend $5, that's no more than $5. So when you see that word no, it negates your statement and it completely flips it. Not only does the symbol change this way, but it also causes you to get an equal sign down there. Because again, that no completely contradicts your first statement. So we're actually going to be going the other way because of that word. Hopefully that makes sense to you because it's like really, really key when you're doing these problems, okay? Let's go ahead and define my variable. So I'm going to say let x represent. In this case, I'm trying to find the maximum number of pencils I can buy. The max number of pencils I can buy. All right, let's go ahead and write the inequality. It looks like I'm going to buy just one eraser, and that one eraser is going to cost me a fixed $1. Like that $1 is not going to change because I'm buying one eraser. What I don't know though is the number of pencils. So I know each pencil is going to cost me 25 cents, but I don't know how many pencils I'm going to buy. So I'm going to call that 0.25x. And that gets me set up, which is great. I realize I missed a bunch of my highlighting. In fact, let's do this. I'm going to go ahead and highlight the more than five, but then I'm going to highlight this because it kind of switched with that word no. All right, let's go ahead and solve this. I got 0.25x plus 1 is less than or equal to 5. Oh no, I got decimals there. Hopefully you remember how I need to get rid of those decimals. To get rid of the decimal, I'm going to go ahead and multiply everything by 100. That way I can move that decimal 2 times to the right. So we're going to multiply everything on the left by 100. And I'm going to multiply everything on the right by 100. When I multiply the first one by 100, I get 25x. And when I multiply the second one by 100, I get plus 100. It's less than or equal to 500. We're going to subtract 100 from each side. I get 25x is less than or equal to 400. Divide both sides by 25. I get x is less than or equal to 16. What does that mean? That means the max number of pencils I can buy is 16. Like I can buy 15 pencils, I can buy 14, I can buy 13, but the max, my x needs to be less than or equal to 16, which means I can get 16. All right, Mark's Canoes rents for $20 per $35 per plus $35 per hour. You do not want to spend more than $150. I see more than 150, and that means this. However, it says I do not want to spend more than 150. That completely negates that statement, which means I need to go the exact opposite way. That means I want my cost to be less than or equal to $150. Okay, I know it's kind of tricky, but once you start seeing it, like it starts making sense. What do I know? Well, I know they're going to charge me $20 no matter what, and then $35 each hour. That each hour gives me that 35x that I'm looking for, plus the one-time cost of $20. Let's go ahead and write our variable. Actually, let me finish highlighting this. I got the 150 here, and that not kind of changed the direction. And I want to define my variable, let x represent. What am I looking for? I am looking for how many hours can I rent the canoe? Let x represent the number of hours I can rent the canoe. Misspelled canoe. There you go. All right, we're going to go ahead and start solving this. Let's see, I got 35x plus 20 is less than or equal to 150. I'm going to subtract 20 from each side. I get 35x is less than or equal to 130. I'm going to divide both sides by 35. Guys, this does give me an ugly answer. And I believe like you just rounded to 7.6. But let me give me 1 second. Let me go ahead and plug that in my calculator. Yeah, that wasn't even close. It should have been a 3.7. Sorry for that. I thought I could remember from the class today, but no. Hey, that decimal goes on forever. We're just going to chop it off at 3.7. So what does that mean? That means we can rent the canoe for 3.7 hours or less. All right, right now, this video is going on 23 minutes, and I don't want to make this super long. So here's what I'm going to do instead. I'm going to have you pause the video right now. I want you to try these last two questions on your own. And then once you're done with it, go ahead and press play on the video so you could see the answers. I'm not going to be going over it. I'm just going to give you what the answers should be. So press pause on the video right now, and in the next 4 seconds, you'll see the answers. Okay, so here is my solutions to each one of those problems. Hopefully you got something very similar, and if you didn't, you can kind of go through my solution and see what I wrote differently. As always, hopefully this helped, and if you have any questions, please feel free to ask.